Hi friends, let us look at a new topic, and this topic is titled quadratic functions. So quadratic functions are functions of the form f of x, which is equal to ax squared plus b plus bx plus c. Ax squared plus bx plus c. That is what a quadratic function is all about, where the a, this a here, and the b and the c are constants, and a is not equal to 0. A, b, and c are constants, and a is not equal to 0, because once it is equal to 0, it means that it is no longer a quadratic. It will now become a linear function, because if you put a 0 there, it will no longer be x squared, it will be 0. So the graph of a quadratic function is called a parabola. So we'll reach a point where we are going to be required to come up with a graph of a quadratic equation. So the graph of a quadratic equation, it is known as the parabola. So the parabola may be in a form of this. When the value of x there is greater than 0, this means that because numbers which are greater than 0 are numbers which are positive numbers. When a is positive, meaning the graph will be like this. This is the way the graph will be. When a is negative, when the value of a is negative, it means that the graph will be like this. So this is what the parabola, or the graph of the parabola, will look like. So this is what we have. So let's look at what follows under the same introduction to quadratic function. So we go to the next point, where we are looking at the meaning of the turning point. So the meaning of the turning point, we are saying it is a point where a parabola turns. Remember, we are saying a parabola, it can be like this when the value of a is greater than 0, meaning positive. When the values are negative, the parabola will be like this. Okay. Now, there is a point which we need to understand. This point is known as the turning point. So the turning point, it is a point where a parabola turns. The minimum or maximum point of the parabola. So, where is this parabola turning? We are going to say it is turning at this point. This is the point where it is turning. So this point there, it is known as the turning point. That point there, it is known as the turning point. What about this one? It is also turning somewhere there. So this point here, it is known as the turning point. Okay, so I'll do this. I also do this. Maybe I say this is the turning point. Is it visible? I want to believe so. Yes, it is visible. So these 2 points are known as the turning. So this is the turning point for this one, and this point here is the turning point of this other parabola. What else do we have? Let us now look at what we mean by saying axis symmetry. So the vertical line, let me just write it here. Okay, so I've written something here by saying note. This vertical line, what vertical line? This vertical line we have just drawn there. This vertical line and this vertical line here is called the axis of symmetry of a parabola. So the question may come to say, find the axis of symmetry of the parabola. What they want you to find, it is to find the value of x of which we are going to reach that point, the value of x at the turning point. This vertical line, it is known as the axis symmetry of the parabola. Why? Because it is cutting the parabola into two equal parts. So let's move. Let's move. Okay, we now look at the turning point. The turning point of a parabola. The turning point of the parabola. What do we have? We are saying the x coordinate. Remember, the turning point, it is a point where the graph is turning, or the parabola itself, where it is turning. Remember, where it is turning, there are some coordinates which are x, y. X, y. So we are saying the x coordinate of the turning point of the quadratic function is given by the formula x is equal to negative b over 2a. This is the formula we use. This is also the equation of axis of symmetry. So the question may come to say, find the equation of axis of symmetry. You just use this formula, which is x is equal to negative b over 2a. So you choose which one is you get the value of b, you also get the value of a, you replace there or you substitute. So to the equation. Then the other point, it is the point to do with the y coordinate. This y coordinate there at the turning point. The y coordinate of the turning point of y is equal to ax squared plus bx plus c can be found by substituting, meaning you substituting the x coordinate. What is to substitute? It is to replace the value of x you have found, or the x coordinate at the turning point. You substitute the value of x into the original equation, into the equation of the parabola. Or you can use the formula. What is the formula? The formula is y is equal to 4ac minus b squared over a over 4a. This is what we have. Then there's a point here. Note that the y coordinate of the turning point is the minimum or the maximum. Normally, this question comes in paper 1, where you are asked to find the minimum or the maximum coordinate of the minimum or the maximum value of y at the turning point. So the value, the y coordinate at the turning point there, the value of y, it may also be called the minimum or the maximum. When is it called the minimum? When your graph, the parabola, the graph of your parabola is like this. Okay? When is it called the maximum? When it is like this. So this one is the maximum, it's on top, this one is at the bottom. It is known as the minimum value of the function of this quadratic function. So this is what we have under the introduction. I hope this one has been mastered. So thank you so much.